Brad, welcome us back to the channel and explain what we have in front of us today.
Yeah, no, welcome back guys. What we're looking at today is the brand new Shining 3D EinScan Trak. So this is Shining 3D's first foray into a track system in the EinScan range. So it's a very good unit, depending on your application that you're trying to do, but it will serve a lot of different industries. When you purchase a EinScan Trak, what you get in is you get the track itself, the tripod, the scanner, the scanner ball, the scanner, the router, the battery's in here, plus the case. So the case is on 4 wheels. So if you're going through an airport or something like that, or traveling with it, it makes it so much easier than 2-wheeled ones. And this is what you get on the inside. So pretty much you've got a calibration pad, calibration bar, some cables, more cables to turn into a wide system, and the calibration plate for the second stage of calibration. So there are quite a few unique selling points for this scanner. So one of them probably is the price, which will be coming out next week. The other one it's very good at is it's able to scan texture. So for example, the painting we've got behind us, so we will be scanning that later. So you're going to see that not only in full color, thanks to the two 5-megapixel color cameras in it, but when you turn the texture off, you'll actually be able to see the brush strokes. So for industries like archaeology or paleontology or arts and cultural things like that, it's very good at collecting that sort of data for it. So textures and things like that. And because it is a track system, what makes it even beneficial for those types of industries, like movies as well, is it can scan large items in a track system in full color. So it's just a very good feature for it. So the other thing is that it's good for, so there is a very unique feature in it, which is the fact that this scanner actually detaches. And you can use this on its own. So which in a track system comes very in handy when, like if you're using this as the scanner and you're scanning, trying to get in under a wheel arch, all of a sudden you're able to pull this off and scan it at a later date. Whether you're collecting the targets beforehand in the track mode or coming in afterwards, you can use the features. So you can get in under there and scan in those tighter areas and things like that. So that's what this is very good for, as well as scanning, say, smaller items on your desk. So it also has it's got the same 19 cross lasers because it comes out of here. So this is actually still quite light. Batteries are in the back. So there's the batteries here. And same on the back here, the batteries plug straight into there. So as a complete system, you get 5.5 hours life out of the batteries. So I would recommend buying some extra batteries just in case you forget to charge them. Okay, so you can use this in a wired mode. However, the whole idea is it's wireless. So the only time you use it in a wired mode is potentially just to upgrade the firmware when there's updates to it in the future, the same way we do with the Trak Nova. As we said, it is Wi-Fi, so it operates on the 5 gigahertz band range, and that's it. So it doesn't operate on Wi-Fi 6 or the 7 gigahertz range. So next, so you can calibrate the SSID as well. So that is another really good feature. So we use that on our Trak Nova. We calibrate it to the local network here that I've set up specifically for our scanners. And this one is also on the same network. And I've also calibrated the router to be the same as well. So whether I'm in the factory or out in the field, I just turn it on and it will just connect directly straight to that network. Let's talk about the range. So the range of the scanner, you can be minimum you have to be is 800 mil from the tracker. Maximum is 4 meters. And then from there, the volumetric range of it is 4200 and 4200 by 4800 and 4000 mil out. So that's the range that this tracker can see the scanner in. And when you're on the screen as well, when you pause it, you're able to see where the ball is in space. So that way you can kind of know, and you can turn on the tracking field of view as well. Let's talk lasers. So in this, when it's plugged into here, it's a 19+19 cross laser. And so you get good data. It's not as good as the Trak Nova with the 50 cross lasers. And then you have the 7 parallel laser lines as well as the single line for deep scanning. With this as well, so the offset for it is when you're using the cross line or the single line, you're still about that 300 mil off the part. And when you're using the parallel lines, you are still that 200 mil off the part. So that's how that operates. To run this system, you don't need a really high spec PC. So the specs recommended from Shining are minimum 32 gig of RAM, which is good. Like a lot of PCs are out there that are like that, laptops as well. I still prefer 64. Minimum video card is a 3060 60 gigabyte. I don't recommend that. I still recommend something bigger. So if you can get something like a 12 gigabyte or more, I think that would really help you. This is a Trak system, so if you're going to be scanning bigger objects and larger objects, you just need that extra space. So yeah, I would go for a minimum 12 gig video card just to do it. And it says a 13th Gen i7 for the CPU, which is fine. That'll do the job. Like the laptop we'll be running this on today is an Ultra 9 64 gig of RAM with a 5090. So it's going to handle anything that this will throw at it. But even when we're post-processing, like I did that painting there at 0.2mm resolution, it will take time because there's just a lot of data to process. Okay, so first thing we're gonna do is we'll turn it on. So I've got the router already powered up. So the software is on, yep. So you should hear when these actually fire up and I turn them on, you should hear them a very faint beep, which means they are connected to not only the network, but the system. So essentially, pretty easy. Press a button, turn on, good to go. Take a minute or so for it to fire up. And so the other thing to consider as well is you will be calibrating this at a certain temperature, and then you try and scan in the similar conditions that it's in. Because if you calibrate at a low temperature, that one just connected, and when you calibrate at a low temperature and the temperature fluctuates, you will need to recalibrate because it won't be as accurate. Okay, so I've just set up a new project group. So here we get to the different modes that we can use. So you can see in the top there, we've got the track mode and we've got laser mode. So what we're going to do initially is we are just going to do track mode. So from here, we've got multiple different things. So we can scan the global markers, which we will do soon. And then we've got scan point clouds, which is what we're going to do now. So, and then you can pick, do you want to acquire texture? Since we're scanning this object here, that's what we're going to do. And then you can pick your different modes. So you got your cross laser, your parallel laser, your single laser, dark and reflective, depending on what you do. If you get most things, I'll probably use the reflective and I drop it down. Or if it's pretty easy, like this will be, we'll just use normal, and if required, I'll bump the brightness up if it needs it. Okay, so we look at resolution here. Just for this quick test, I'll just do something normal, I suppose. Quiet texture, confirm. So if I'm scanning, like when I scan that painting, I know I did a lot higher resolution, but for this one, we will just do this. Okay, so essentially, so the next thing that I like to do is I want to make sure in a track mode, I want to make sure that I'm able to scan the most of this in the single frame. So put it this way, if I had to try and tip this up and down or avoid doing that, I want to try and so I can capture the most amount in one go with this, seeing this, and make my life as the scanner a bit easier. So I'll put this close to the edge and I'll angle it like that. I'll set this up. Okay, so the reason I'm probably going to do a lot of this from behind is there's so much there that could potentially be harder to get. A lot of it we'll be able to get from the front. So might just, press play once and that'll bring up the preview screen. You can kind of see what's going on here. So blue means you're too far from the object, green means good, red, too close. So let's go.
And talk to me, Brad, what are you aiming for here, and what range of motion are you trying to get to capture this data accurately?
So what I'm trying to do is I'm using the angle of the scanner. So the way that I hold it and the way that I move it is I'm trying to scan certain areas of it so that it just makes it easier. So it's probably, I'm not even looking at the screen. So it's probably capturing it pretty well, which it has. And because I'm more focusing on the angle. So probably the one thing to remember as using track system is do not stand between the scanner and the tracker. So,
because it will capture that data?
No, it'll just won't work. So if you do that, you can't see it. So it's not going to work.
Gotcha.
So that, it takes a little bit getting used to, but once you're in the habit of it, you just know where the tracker is and you just don't stand in its way. And even that even comes down to how you, like what I've done here, set this up so you can capture the most amount of data without actually, so now I can look at the screen while I'm doing it. As you can see on the screen, it's a very nice color. It's fantastic. And then you can actually see, so this is a 0.6 mil. So this is still just point cloud, so it hasn't meshed itself yet. So we can do a little bit of tidy up and we can mesh it. So that's just a quick scan. So you could probably spend more time to capture more data. So what we might do though, actually, is I'll just delete the base just to make it a little bit easier, and then we'll just show the next mode, or not the next mode, but the alignment process. So I like to use the polygon tool here. Oh, good, it did it. So what we're going to do is we're going to create a new project. We're going to rotate this around. So I've got it near the edge, primarily so that when I'm holding the tracker, the scanner, I can actually get in up underneath it.
And does moving the position of the item you're scanning change much?
Well, I've moved both the tracker and the scanner, the part now. So yeah, what we tried to do before just won't work because everything's moved. So what we're going to do is we're going to create a new project. Still run the same settings. So these are these mortar settings here: local enlarged view, data quality indicator, tracking volume. So pretty much with the tracking volume turned on, what I was talking about before, you get to see the scanner floating around on the screen. So like that there. So we're in preview mode. So I'll just get rid of the tracking volume. So the other thing I like to do as well is, as you see in the top right hand corner, you can see the distance. So I do like that because it just helps me with a visual reference. So yes, straight away it captured that data very quickly, very easily. So what I brought it, well actually why I did move it is I just wanted to get in under here.
Can you then merge?
That's what we're doing.
There you go.
So the reason I've done this extra project is to show you how the alignment works.
So even if you can't capture some data because it's in a certain position and you can stand in front of the tracker and it'll block the data, you can then move it and then merge it back together.
Correct.
With the data you have.
You can align the data and then it will just automatically merge it. So we don't need to scan too much. It's probably the areas we didn't get before. So like under here, this is why I've done it near the edge of the table. Alrighty, so what we do next is, so I like to use a mouse like this as well because it's got the trackball and I can be standing anywhere. So we use the alignment. So there's 4 alignment features. Since we haven't used markers, there's only 2. So we got auto feature alignment, which is what we'll do first. So what it's going to look for. So There's a bit of table there. It's going to look at the features of these parts and auto align them. The next one, so if there's, say you got like a dual wheeler or something like that, the auto align can fail because it's seeing too much of the same patterns and it will shift things up. So I've seen it before, and then that's when you move to the next one and use manual feature alignment, and you pick the certain parts of the item you've scanned to get them to start the alignment process there. So the next one is by markers. So if you've got a multiple project, and you can align them by markers that way, or manual markers if you, for the same reason, or you wanted to trick the data to get it to do something else. So what we'll do now is we'll supply it, let it do its thing, which shouldn't take too long, and there we go. As you can see, perfectly aligned. And 2 scans. So now it looks great. Turn the texture off. And then from there, we essentially just pick which one you want to do. So this is smart. So depending on what you're doing, like for the metrology stuff that we do, I just leave it as none. But this is artwork, so we'll just do standard and standard. You can pick manual settings here if you like, and just let it process. So because it is 0.6 mil, might take a little bit of time, but you know, it's not too bad. If you wanted to, you can do texture adjustment as well, or texture remapping, which can take some time. So the texture adjustment is just, you know, the brightness and the contrast of it. So to kind of get a close approximation of, there we go, that looks close enough. So we will have an expert here in the next few weeks that does this particular type of job for a living. And then there's your data size. Actually 0.6 mil, it's not too bad, 138 meg. So, and you can, from here you can decimate it to be whatever size you like. So sometimes when we scan cars and car bodies and things like that, the data can be well over a gig. So depending on what you're trying to do, we can decimate it down to suit your needs. Okay. So right now we are going to enter the hybrid leapfrog mode. So what the hybrid leapfrog mode is, we've got the tracker in a locked position where it is right now. And from there, we use the handheld unit to scan the targets. And once that's then completed, then we can scan the data. And once we've scanned that data, we can then pick the tracker up, move it to a different location, rescan the targets with the handheld again, and we'll automatically align the 2 different projects together. So let's get this going. So there's the warnings of what you can do. Okay, so first thing first, let's scan the markers. Okay. So we'll scan these. We're getting a bit far there, but it'll do the job. Okay. So we've scanned those. Just to make my life easier, we'll just jump straight into scan point clouds, and away we go. Look at that, easy peasy, just capturing data. So what I want to do is we will stop there and just do maybe just a little bit just there. Okay, so we pause that. And then we hold the long press step. Oh, I think it's this button. Next leap. So moving to the next leap. So let's just move this. Oh, let's see if I got this right or I got it wrong. So we can keep scanning these targets. As you saw, it just leaped straight to it, hence the term leapfrog. So we've captured these targets just to get it to align. Marker alignment completed, as you can see on the screen. But I just want to get a few more and go from there. So now we go straight to scanning point cloud. So as you can see, straight over the top, adding data to it.
And Brad, explain to me why a technique like this can be good.
So technique like this can be good because you can just move, you just keep adding data to the same coordinate system without having to stop.
Yeah. And it would make it easy to mesh it all together.
It does, in a way, yeah.
In a singular step.
Yep. Okay, just trying to pause that. So we'll see how it, oh no, don't, yeah, you just keep going. So we're just looking at the data here. So you can see where the overlap, where it's not great data because of the yellow there. So if we just jump out of the exit hybrid transit station, well, I just want to have a look at how the data will actually mesh together on it. So we've got a very clear transition here. Let's see how it looks. So I'll just leave the standard settings pretty much. And look at that. So you can see where that transition between the two data sets was here, and it looks neat. So yeah, that's worked pretty well. So that's how the hybrid leapfrog works. Okay, so now we have moved into the laser scanning. So just before we do that, we might just quickly run through some of these. A lot of the settings are the same as what we had on the Trak system. So within the independent scanning mode, you can scan the global markers, jump straight to point cloud if you like. You can also acquire texture on it. And so local resolution is not activated yet because we haven't scanned anything. Now, what I wanted to highlight, the fact is, because we are now in the standalone mode, in the laser mode, you can either align by feature or marker. So we might bring the statue out again in a second just to show you how it can track by feature. And then we might just scan the wall we've got behind us because it's already covered in targets. So, or might scan, I'll bring this part over to the workbench and we'll scan that. Okay, so just for this, we will use 0.5 mil. We'll leave it on markers for now. And so we've got markers. We'll put onto reflective. We'll drop the brightness. It's not that bright, not that reflective, I should say. And okay, so initially, I'm just want to use it just like this, which we can. And yeah, there may become an instance where, all right, I just got something on the bench. It's already in its pre-configured mode for Trak scanning. I just want to scan, so that we can do. So what we're going to do first is just scan. So as you can see, it just works straight up. Still got the two batteries in there, so you can scan for longer. So I wasn't watching what I was doing. So there we go, transitioned on the underside, and so also for here, we can increase the brightness, and at the same time, let's just switch over to single laser mode. We'll just start capturing data down here. See how it goes for the deep hole scanning. Not bad. Here we go. So it is capable of that. So we'll just jump back this just so I can fill a bit more data in. So it's a bit neater. So, yep. Okay, so as you can see, it is clearly doing its job just like this. So you can scan the global markers first, which we'll probably do when we do it the next mode. But yeah, as a very brief look, there we go. So what we might do now is we'll just power this unit down, and then we will just disassemble it and just have it running as a little standalone scanner. So, okay, so she's powered off. You'll see it on the screen in a second when it will lose its connection. So you pull the batteries out. undo this here. And then, like your last. So this takes a single battery in the back. So first time I've ever used it like this. Okay. Power it on. Wait to reconnect. So now that this is back on and running, let us just do it quickly, pretty much the same thing we just did, and see how it goes. So there we go, just like that.
So you can use it in the probe, or you can use it handheld?
Correct, yeah. Yeah, you can use it as part of the tracks, like in its cradle for in the track mode and its ball configuration, or just like this. So as you can see, it just scans it. And even if you do scan, which we will do now though, because we didn't do it on the last one. So if you do, for example, let's just scan the global markers first, just these ones here. So you just see what it has the ability to do. So what we've got here, we'll just jump straight to the point cloud. So you can add global markers. So what we're looking at there is we get in straight into the scan. Okay, and then as you see, we're adding the markers to the scan. But that's pretty much all I wanted to show on that one. And it works. And then we wanted to flip it around and align it, we can also do that as well. So what we're going to do right now though is we'll get rid of this, and I will grab that statue before, because it is feature rich. What I want to do is scan point clouds, but we want to do by feature. We want to acquire texture. We just use this, it's not super bright. So it tells you your working offset distance. Okay, so let's just see how it goes. Start with a feature-rich area. So no markers on here. 0.5mm resolution. Let's just have a look-see. There you go. So we can post-process that, it will tidy itself up. Just mesh it. It shouldn't take too long. If I'd done a higher resolution, like 1mm or something like that, would have been much quicker, probably finished by now. And we'll see how the data is, and that should be wrapped this one up. But it's done it in texture, so once again, once you get through the post-processing, you can do complete texture remapping if you like, and to give you that very good color definition and quality, and modify, which we'll do here again, just the brightness and contrast. There we go. And there's it right there.
Now, Brad, obviously an incredible scanner that we've seen today. Who is it for?
So there's a range of industries this is good for. So one of the good ones is, which we've tested it already, is marine. So in this one, it's very good at scanning, say, the hulls of boats on the inside, so for their decking foams and things like that. They can also, because the boats aren't necessarily 100% to CAD, they can also use it to scan and inspect and have a digital inventory of all the boats that they've manufactured. For automotive industry and also the marine industry, very good for upholstery. So what makes this really suitable for that is the fact that you're able to just put the track down and just scan everything. And because you can scan in color, especially in the upholstery side, you're able to see all the seams and things like that. So when you're doing in like the exact flat, things like that, you can sketch your surfaces and we'll flatten it out so that you can do it. And that's all over where the seam patterns are. And it's a very, very helpful, very quick and efficient solution for that. Now for the industries, we've got film, and we've got things like for the museums and whatnot, the color features in this will make it a fantastic addition for those. For example, if you've got some dinosaur bones or you've got some heritage parts that have come from all over the world, you would be able to do a 3D scan without actually putting anything on it and capture that data in full color, as well as every little nuance depending on the resolution that you do use. So we've done that with a couple of the items here, and namely like that painting there, which you've already seen. You're able to seal that texture and things like that, and it just makes it so much better. So there are a few of the industries. There's more industries that it's applicable to, and if you contact us, that's when we're able to start tailoring a solution to help you with that.
So certainly versatile, and that's what I'm hearing now, is that it's a number of different industries going to be able to use this.
Yes.
I know you might not be able to disclose this, but everyone watching is probably wondering, where does this price point sit? And I don't know if you're allowed to say it, but where would you consider this price point in relation to all the other Shining 3D scanners on the market?
So it's, when it comes to the other Shining 3D scanners on the market, it's more than a Regal. So the Regal's already a very good price for what it is. For the price point that this at, it is fantastic. Like, it is a great price point, and especially for what you get in the package. It is cheaper than the metrology units, so which is a given, and it's a lot cheaper than the EinScan Libra.
Yeah. Okay, and if someone were to buy one of these, obviously it's a skill to learn how to use it and know what you're looking for within it. Does yourself and Zero 3D provide training, or
for an additional fee for this unit? Yes, we can provide a full comprehensive training for this unit as an additional fee if you would like to do that. When you buy the metrology systems from us, like for example the Trak Nova, that comes in that system. You get free training in that, but with this unit you can get training, you just have to pay for it.
There you go. True. So an awesome versatile unit, good price point, versatile for a number of different businesses. This is a winning product, would you call it?
Oh, I think it's a very, very good product for a lot of different industries, so that people can actually take that next step in their journey of 3D scanning. So it gives them a very good platform and a very good way to learn how to move with a Trak scanner. And hopefully you go from here, and depending on your industry, you jump up into those Trak Novas, because they're just much more accurate and more versatile. Probably the main thing that this can do that the Trak Nova can't is scan color, and there's just a lot of things that this can't do that the Trak Nova can.
Yep. Yeah, right, okay. So if someone wanted to buy one of these, what's the process look like? So
the process is, you can either contact us directly, so our email address will be on this video, and the other one is you can just buy it directly from our website at 03d.au.
There you go. So not too hard. And wait times on acquiring?
Probably looking around about 5 to 10 business days.
There you go.
Awesome. So it's not too bad, and we can ship direct to your door.
Perfect, mate. Well, it's been great to learn about this today, Brad, and we look forward to more videos in the future, hey?
Yep, no, goodbye, and thanks for watching.